We can also find antiderivatives, or indefinite integrals of power functions. To do that, we'll start off by taking the derivative of a power function, which would give us n times x to the n minus 1. Now we could look at dividing both sides of this expression by n to rewrite this as d over dx, x to the n over n is equal to x to the n minus 1, which tells us that the antiderivative, the indefinite integral of x to the n minus 1 dx, will be equal to x to the n divided by n plus that constant c at the end. This doesn't quite match how we generally see power functions written. We don't normally see them written as x to the 3 minus 1 power or something like that, so we're going to make a slight modification here. We're going to let a new variable m equal n minus 1, which means that m plus 1 will be equal to n, and we can go ahead and rewrite this result we just came up with as the antiderivative of x to the m dx. So now what we're integrating is a power function, is going to be equal to x to the m plus 1 over m plus 1 plus that constant c, which I'm running out of room for, but we know is there. That is, to find the antiderivative, the indefinite integral of a power function, we increase the exponent by 1 and divide by that exact same value. To take a look at that in example 2, we want to find the indefinite integral of x. Even though we don't write it, this is x to the first power. So our indefinite integral would be x to the second power. So we increase that exponent by 1 and divide by that exact same value, and then make sure we add plus c onto the end of that. We can check that result by taking the derivative, which would give us 2x over 2 plus 0. 2 over 2 would cancel, so we end up with just x, which was the function that we started off with. In example 3, now we have the indefinite integral of x to the 6th power. So we take x and increase the exponent by 1 and divide by that exact same result, and then tack on plus c at the end. And we can always check these antiderivatives or indefinite integrals by taking the derivative of our result and making sure we get back to that expression that we started off with. Since that checks out, we know that we have the correct antiderivative for x to the 6th.